quadratic functions in all three forms: vertex form, standard form, and factored form. What we're going to look at today is what's called or referred to as the nature of the roots. And if we think about the number of roots a quadratic function has, it could have two roots that are distinct or different. So if I think about a quadratic function that opens up and the vertex is below the x-axis, so it's crossing over, that would give me an indication of that. So something like that, that's crossing over the axis. Or I could have something like this that opens down, the vertex is above the x-axis and crosses over. The other option is I could have something that the vertex sits on the axis. So there's really only one distinct real root, or what's sometimes referred to as two equal real roots. And the function can open up or down based on the value of the leading coefficient, or the value of a in the equation f at x equals a times x minus h squared plus k. Or it could have no real roots. So if I have a function that opens up and the vertex is above the x-axis, or a function that opens down and the vertex is below the x-axis, I won't get real roots. The question we have today is, how can we figure that out? And we're going to lead into it with something called the discriminant, or the nature of the root. So if I think about the quadratic formula that we talked about yesterday, this part under here, b squared minus 4ac, is called the discriminant, and it's denoted by a capital D. Okay? So we're just going to practice calculating the discriminant. If I think about this, a is 2, b is 6, and c is 1. So to do the discriminant, b squared minus 4ac, again, I'm going to put brackets around, and I'm going to do 6 squared minus 4 times 2, minus 4 times 2 times 1. Sorry, I got lost. And I use my good friend BEDMAS, and I evaluate, and I've got a positive discriminant. It's just number crunching to find the discriminant. Don't make it more than it needs to be. Discriminant, b squared minus 4ac. The value of b in this situation is -5, so I put -5 in brackets. And the value of a is -1, and c is -7. So -5 in brackets, subtract 4 times -1 times -7. And negative times a negative is a positive, so the -5 squared is positive 25. Be very careful of that when you're working with b squared, that you keep the negative sign on the b inside the bracket, because that is part of the value of b. Negative times negative times negative is a negative, and the discriminant is negative. Part C. Discriminant, b squared minus 4ac. The a value is 3, b is -1, and c is positive 8. So when I plug in, I'm putting -1 in brackets for b squared, 3 in brackets for the a, and positive 8 in brackets for c. -1 squared is positive 1, and negative times positive is a negative, and I end up still, again, with a negative discriminant. Which makes sense that I could end up with positive and negative discriminants. There's nothing saying something has to be positive or negative. F at x, x squared minus 6x plus 9. I know something interesting about that, and hopefully you've picked up on that looking at it, but we're not going to talk about that yet. The a value is 1, b is -6, and c is 9. Plugging those numbers in, I end up with a -6 all squared. Subtract 4 times 1 times 9. And -6 all squared is 36, subtract 36, which is 0. So I can really take on any number I want for my discriminant. Oh, and I should know something about this function already too, but again, we'll talk about that later. If I look at this, the a value is 1. There isn't a linear term. That means b, in fact, has a value of 0, and the c is -9. So when I do b squared, I'm going to do 0 squared minus 4 times a, which is 1, multiplied by c, which is -9, and I end up with a discriminant of 36. And finally, one more to practice. The a value here is -2, the b value is -4, and c is -2. I always start out by writing those three values out, the same as I did with the quadratic formula. That way I'm drawn to it and I don't make a careless error. And if I did make a careless error identifying them, the teacher marking my work might realize that and give me part marks. So the b value is negative 4 squared minus 4 times a, which is negative 2, times c, which is negative 2 also. Negative 4 squared is 16. Negative times negative is a negative. And that's got a 0 discriminant. Well, that was loads of fun. That was just number crunching and substitution. That was really, really easy. So what I want you to do now, because it can't all be easy, is I want you to rewrite each of those 6 equations in vertex form by completing the square. I'd like you to graph each function using transformations, and then try to determine the connection between the graph and its discriminant, because that's where we're going to lead tomorrow in class.